in this video I will be solving more question of Newton-Raphson method, and it will going to be more complicated, and I will be solving code also in the last of the video. So let's start with this video without wasting our time. So today we have this question. We are going to solve this with the Newton method. So here is our f of x, which is x cube, by converting this into this equation, x cube minus 48. So let's first take the derivative of this equation. F of x is for x cube minus 48, and derivative of f of x will be 3x square. So we have got the f of x and derivative of f of x also. So now let's start with our working. First of all, we have to find 2 points between which the root gonna lies. So let's start with 0. If we put 0 in this equation, we will get minus 48, and if we will going to put 1 in this equation, we will going to get minus 47, and if we will going to put 2 in this equation, we will going to get minus 40, and if we are going to put 3 in this equation, we are going to get minus 21. Until now there is no sign changing, so let's go for further. 4, if we put 4 in this equation, we will get 16. So as you can see, signs are changed. The root gonna lie between these 2 points, which is 3 and 4. So let's consider these 2 points, 3, 4. Let's take the average of these 2 points. Average is equals to 3 plus 4 divided by 2, which will be 3.5. So as we have got the point, this will be our x naught. So our x naught is 3.5. So now put this x naught in this f of x and f derivative of x. So if we put this f of x naught in this equation, we will going to get fx naught, which will be equals to minus 5.125, and the derivative of f of x naught will be 36.75. So as we have got all the 3 values which we are gonna need in the formula, so now just put these values into the formula, and the formula is xn plus 1 equals to xn minus f of x upon f derivative of x. So let's put these value into the formula. X1 will be equals to 3.5, which is x naught, minus f of x naught, which is minus 5.125, and divided by f derivative of x naught, which is 36.75. Now solve this value into the calculator. It will be 3.64, round off, approximate. So now we have got x1. Now we will do working for our x2. X1 is 3.64, and derivative of f of x1 will be 0.228544, and f derivative of x1 will be 39.7488. So as we have got all the 3 values which are gonna need in the formula, let's work for x2. The working for x2 will be equals to x1 is 3.64 minus 0.228544 divided by 39.7488, and the value we will get for x2 will be 3.634. So this is our x2. As we have seen, x naught, we have got x naught, which is 3.5, and f of x4 and x1 was 3.64, and our x2 is now 3.63. these are the 3 points on which we were working. So we can do further more on x3 and etc as much as we want. So this was our Newton method, and this was our second question. So now let's move on to our coding. So this is the coding portion of this video. In this portion I will going to talk about the code of Newton-Raphson method. So this is the same code which we have done in our previous video. Now let's talk about this code. So first of all, we have the function which is f of x, which carries our equation. Then we have g of x, which carries the derivative of our equation. Then we have another function which is Newton-Raphson method. Then we have it has attributes of x naught, e and n. N is the number of iteration, e is toll, and x naught is our value. So then we have print this line which tells us that our code are started from here. Then we have initialize a variable by 1 a step and this will count the number of iteration performed. Then we have set flag which is 1, and then we have set another variable which is true, condition equals to true. And then we have our while loop condition. If the condition is true, this while loop going to work. If the condition is going to get false, then it will going to break. So after coming down, we have another condition which says in the while loop we have another condition which says if g of x double equals to 0, it will going to print divide by 0 error, and it will going to break the loop over here. Then we if it is not valid, that we are going to pass this condition. Then we are going to go to the formula of x1 on which we are going to get our x1. Then we are going to print the number of iteration performed and all the outputs over here. Then we will going to replace x0 by x1. Then the step will be increment by 1 after every iteration performed. Then we have our condition if step greater than n number of iteration, then it will going to break get the flag 0, and it will going to break the loop over here. Then we have condition over here, condition equals to absolute f of x1 greater than e. If it is going to get true, the loop will going to perform. If it will going to get invalid or get false, the loop will going to break over here. This line will decide whether the loop is going to proceed or break. Then we have another condition which say if flag double equals to 1, it will print this line required true. Then else it will going to print this line. Then after this while loop going to end over here, then we have our inputs over here, which is x0, e and n. X0 input will be going to get our x0 value, and e will going to get our toll, and then we have n number of iteration we have over here. Then we are going to convert x0 and e into float values, then and n into integer value. Then we have called our function over here with the x0 attribute x0, e and n. Now let's run this code and see what will going to be our approximate root. We have found 3.5 as our x0 in our previous calculation. So write 3.5 over here and enter, and we have set a toll of 0.0000001 something. Now enter this over here, and we were going to set our number of iteration 100. Now enter. It performed 3 iterations over here, and we have our required root is 3.63 something. So this was the video of coding. So thanks for watching. So this was it. It was the video on which we solved some more questions of Newton-Raphson method. So hope you learned more about Newton-Raphson method and enjoying this series. So thanks for watching. Don't forget to subscribe our channel.